Hi students, today I was asked to tape a video of how to factor the difference or the sum of cubes using the formulas that we were given in our notes. So I'm using the factoring flowchart that we were given in class a few weeks ago, and I am turning to the page that says sum and difference of cubes. Some of you guys still might have this. So I have two different formulas. I have an a cubed plus b cubed formula, and this is the sum of perfect cubes. And so when I have that, I take a and add it to b, and then I have a squared plus a times b plus b squared. Oops, I'm sorry, this is going to be a negative a times b. Then if I have a difference of cubes, then I'm going to have a minus b times a squared plus ab plus b squared. And this can be found on the front of your packet. So the next step that we need to do is to go over here, and so we have to figure out, I know that x cubed is equal to a cubed, so I want to find out what a is equal to. So basically, I'm going to take the cube root of each of these terms. So a is going to be equal to x, because the cube root of x is x. Now, some of you asked today in class, how do I find the cube root using a calculator? I can take this, instead of saying x, the cube root of x, I can say x cubed, and then I can take the 1/3 of it. So that's the same as saying the cube root of x. And then I take, I know that b cubed is equal to 27, so I take the cube root of b cubed, and that would be 3, because 3 times 3 times 3 is 27. So at this point, I know a is x and b is 3, and I use my formula. I use my sum because I'm adding them together. So I have x plus 3, and then I multiply it by, then I have x squared, because a is x, so I just have to square the x. And then minus 3 times x, because ab is 3x, plus b squared, which is 9. So at this point, if I was going to find the roots of the equation, I could set this factor here equal to 0 to solve for x is equal to -3, and then I could use the quadratic formula to solve for what x is equal to over here. So in this case, I would say the opposite of b is 3 plus or minus -3 squared minus 4 times 9 times 1 divided by 2a. And so I have 3 plus or minus the square root of 9 minus 36 over 2. And so then I have 3 plus or minus the square root of -27 over 2. And then I have 3 plus or minus 3i times the square root of 3 over 2. So my roots would be x is equal to -3, and then x is equal to 3 plus 3i times the square root of 3 over 2, and 3 minus 3i times the square root of 3. So that helps you with this one. Number 4 is an important one because it looks very similar to what we had today in class. So I'm going to work on number 4, and again I'm using the same formula because it's the sum of perfect cubes. So in this case, I find out that a is going to equal -3u, because I take the cube root of -27. So in my calculator I can do -27 to the 1/3 power, and it's going to be -3, and then u, the cube root of u to the 3rd power is u. And b is going to equal 5, because 5 times 5 is 25, times 5 more is 125. So at this point, I can use my formula, and I have -3u plus 5. And then I have -3u, and I have to square that term, because a is -3u. And then I have to multiply, so a -3u times 5. And then I have to square the 5. So at this point, I have -3u plus 5, and then I have 9u squared plus 15u plus 25. And from here, I'm going to set this factor equal to 0, and I'm going to solve, and it's going to be -3u is equal to -5 divided by 3, so u is equal to positive 5/3, and then I'm going to use the quadratic formula again over here to solve for what u can equal to there. So let's move on down to 5. So don't forget to use the quadratic formula, and I'll let you guys do that. Same as what we did in number 1 to solve for what u is equal to. Then moving on down to this one, this is the difference of perfect cubes, and in this case a is x and b is 3, because it's the difference, so I just look at the 3 times 3 times 3 is 27. So I have x minus 3, and then I have x squared plus 3x plus 9. And then again, I think it's very similar to this one up here, except for it's a positive 3 instead of a negative 3. And so I solve for x minus 3 is equal to 0, so x is equal to 3. Solve for over here, x can be equal to negative 3 plus or minus the square root of 9 minus 36 over 2. And so at this point I have x is equal to negative 3 plus or minus 3i times the square root of 3 over 2. So these would be my answers for this one. So hopefully that will help you with these types of problems.